Good afternoon to everyone. We will have rational functions today. I've discussed polynomial functions, how to sketch their graphs yesterday in my Math 21B class. Okay, wait. Someone sent a message in the chat. Okay. And there, I've listed down 3 steps for sketching the graph of a polynomial function. Step 1 would be to find the intercepts. Step 2 would be to construct the sign chart, and step 3 would be the actual sketch. Now, for the steps in graphing rational functions, we just add 2 additional steps. So let me first define what a rational function is. A rational function is just like your rational number. Remember, a rational number is a ratio of 2 whole numbers or integers. So the counterpart would be polynomial functions for integers. So a rational function would be simply a ratio of 2 polynomials n of x, d of x, where n of x is the numerator, it's a polynomial. D of x is the denominator, it is also a polynomial. Now, for rational functions, they would have vertical and horizontal asymptotes. So let me first give you the procedure for finding those asymptotes. For vertical asymptotes, they are very easy to find. You simply inspect the denominator and find all the zeros of the denominator. In other words, just set d of x, the denominator, to 0. For the horizontal asymptotes, just compare the degrees of the numerator and the denominator. And there are 3 possibilities. First, the degree of the numerator is greater than the degree of the denominator. If this is the case, then there is no horizontal asymptote. However, in this course, we will not be interested in such cases. So you won't be having such kind of questions in the next departmental quiz. So we will just have cases 2 and 3. For case 2, the degree of the numerator and denominator, their degrees are equal. If that is so, all you have to do is divide the leading coefficients of the numerator and denominator. And that ratio would be the horizontal asymptote. Don't worry, this will be illustrated in an example. Last case is when we have, or where we have the degree of the numerator less than the degree of the denominator. If this is so, then there's always the same horizontal asymptote no matter what those polynomials are. The x-axis, whose equation is y equals 0, is always the horizontal asymptote. So consider this function here. F of x equals x squared minus 1 all over quantity x plus 2 times x minus 3. Here are the steps for sketching the graph of a rational function. Step 1, find the domain. As opposed to polynomial functions whose domain or domains is always the set of all real numbers, since it's always defined no matter what the value of x is. For rational functions, since we have a denominator and division by 0 is not allowed, that means that we have to find the domain. If you inspect the function here, the denominator will become 0 if x is negative 2 or positive 3. So that means the domain is all real numbers x except those 2 values. Step 2, find the intercepts. There are 2 x and y intercepts. Again, for the x-intercepts, as I have discussed in the previous video, all you have to do is equate the function f of x to 0. But since the function involves a numerator and the denominator, if you do that, if you equate this to 0 and cross multiply, eventually you will just be setting the numerator equal to 0. So for rational functions, just equate the numerator to 0 to get the x-intercept. So let's do that. So this is the numerator. Equate that to 0. You get two zeros or x-intercepts, namely -1, 1. For y-intercept set, as always, set the variable x to 0. In other words, plug in x equals 0 here. And if you do that, you plug in 0, replace x by 0, we have 1 over 6 for the y-intercept. Now, those intercepts will be plotted first before we sketch the graph of the function. Next, step 3, find the asymptotes. There are two, vertical and horizontal asymptotes. For the vertical asymptotes, there may be more than one, there may be none. Unlike for the horizontal asymptote, there's at most one. So for finding the vertical asymptote, set the denominator to 0. For the x-intercepts, you set the numerator to 0, but for the vertical asymptotes, you set the denominator to 0. If you go back, you see the denominator is x plus 2 times x minus 3. We equate that to 0. We get the vertical asymptotes whose equations are x equals -2, x equals 3. Take note that there's a difference between just writing -2 and 3. If you just write -2 and 3, those would not be equations of vertical lines. For vertical lines, you have to put in the equation of those lines, and that is by writing x equals the constant number there, or the zeros there. So x equals -2, this is the vertical line that passes through the point -2 of the x-axis, and then x equals 3 is the vertical line that passes through x equals 3 of the x-axis. Yes, is there a question? Okay, none. So for the horizontal asymptotes, we look back, we see that the degrees are the same. The degree of the numerator is 2. The degree, by the way, is just the highest power appearing in the expression. And this is also of degree 2, since this is degree 1, this is degree 1. So 1 plus 1 equals 2. Or you just expand, this will be quadratic. So degree 2. So same degrees. So what do we do? If they have the same degrees, by the way, you just divide the leading coefficient. What's the leading coefficient of the numerator? It is 1x squared, so the leading coefficient is 1. For this one, if you expand it, it will be x times x, so that's x squared, that's 1 also. So divide that to 1 divided by 1, you get the horizontal asymptote y equals 1. Okay? This is the leading coefficient of the numerator, this of the denominator, divide. So the horizontal asymptote has equation y equals 1 is the horizontal line intersecting the y-axis at 1. Next, the sign chart. The sign chart will tell us when where the graph is above the x-axis, where it is below the x-axis. So there's the sign chart. I'll leave the details to you. And we can tell from the sign chart that the graph is above the x-axis here, from -infinity to -2, below the x-axis here, above, below, above. And with the sign chart, together with the asymptotes and the intercepts, we are ready to sketch the graph of the function. So plot the intercepts, draw the asymptotes, use the sign chart. Those are just the things you have to do in order to sketch the graph. So as I have discussed yesterday, the sign chart tells us where the graph is above or where it is below the x-axis. And also, since we have asymptotes for rational functions, the sign chart will tell us if the graph is asymptotic towards the positive y direction or towards the negative y direction, okay, near an asymptote, as I will show in this example. So looking at the graph here, which I've already pasted here for you to see, I will just be explaining how to arrive at that graph by looking at the sign chart. So if you look at the sign chart, first of all, -2 is a vertical asymptote, x equals -2. Now, to the left of -2, we have a positive sign. To the right of -2, we have a negative sign. So to the left of -2, it will be asymptotic towards positive infinity or the positive y direction. And to the right, asymptotic towards the negative y direction, negative infinity. So if you look at the graph, we see here that the graph is asymptotic to this asymptote, x equals -2, towards the positive direction, and to the right, towards the negative direction. If we look again at the other asymptote, x equals 3, it will be asymptotic towards the negative y direction from the left and towards the positive direction from the right, as verified by the graph. So negative the y direction, positive y direction. And then we also have the asymptotes there. By the way, -1 and the intercepts, -1 and 1. The vertical asymptotes, and not indicated, but it's this one, that's the horizontal asymptote, y equals 1. If you can see that very faded line there. Okay, anyway, you can just look at the coordinate here, 1. So imagine that horizontal line, that's the horizontal asymptote. And notice also that the graph is asymptotic to that asymptote towards positive infinity and towards negative infinity. And you just connect, okay, the intercepts, join the curve, and you will have the sketch of the graph. Now, it may seem difficult at first, but with another example, this will all become clear. So is there any question so far? By the way, practice exercises are given at the end of this section on polynomial and rational functions. I leave that to you as an assignment, not to be submitted, okay? Although I will be giving an assignment. Now let me switch to my tablet now. Wait a minute. Forgot to set this up.
Baka nakaga na.
Don't forget to mute your microphone. Okay, consider this one here. The function y equals x all over the quantity x plus 3 times x plus 1 times x minus 2. So let's sketch the graph of this one. You may already do it as I discuss the solution. So first, let us find the intercepts. Well, the domain is very obvious. So I won't be writing it down since I'm using a tablet. But anyway, the domain are those values that make the denominator 0 in value. So -3, -1, and 2 are to be excluded in the domain. But writing down the intercepts, we have for the x-intercept, how do we get the x-intercept? We set the numerator to 0, and we only have one factor there, so you get x equals 0. And obviously, since that's the origin, that will also be the y-intercept, but let us verify. To get the y-intercept, all you have to do is set or substitute x equals 0. If you plug in 0 for x in all the x's there, you'll still get 0, because this is 0. Okay. Then the asymptotes. For the vertical asymptote, you look at the denominator. There are 3 factors, so that would mean 3 vertical asymptotes. Namely, you equate that to 0, the denominator to 0, you'll get the following. The vertical line whose equation is x equals -3. Also, x equals -1, vertical line yan, x equals 2, vertical line. Not the numbers -3, -1, 2, but the lines whose equations are given by those. And then for the horizontal asymptote, just compare the degrees. The degree of the numerator is 1. The degree of the denominator is 3. 1, 1, 1. So that's 3. That means the degree of the numerator is less than the degree of the denominator. So we have case 3. And case 3 says again that if that is the case, the horizontal asymptote is always the x-axis, whose equation is y equals 0. That's the x-axis, not the value 0. And then the sign chart. Okay. We have the critical numbers, by the way. What are the critical numbers? How do you get the critical numbers? You set both numerator and denominator to 0 this time. So for x-intercepts, set the numerator to 0. For the vertical asymptotes, set the denominator to 0. But for the critical numbers, you set both numerator and denominator to 0. The values obtained are the critical numbers. So from the numerator, we have 0. Okay, this one. From the denominator, we have -3, -1, and 2. And the correct order of signs is as follows. From right to left, positive, negative, positive, negative, positive. We have 0 at 0 and ND elsewhere. There. So again, the sign chart will tell us if the graph is above the x-axis or below, depending on the interval, the sign of the interval. And also, it will help us know in which direction the graph is asymptotic to, whether the positive y direction or the negative y direction. So let's sketch the graph. Of course, draw your axis first. Okay, not so accurate scale, but anyway. Can you hear me clearly? Tell me if I'm just like already whispering, okay?
You're clear, sir.
Okay. So first, plot the intercepts. There's only one intercept. It's both an x and a y intercept. So there's the intercept. And then draw the asymptotes. So they are negative, x equals -3. If you don't have a different colored pencil or pen, just use dashed lines. I'll use solid lines here. X equals -1 and x equals 2. So the graph will be asymptotic to those lines. So to know if it's in the positive direction, you have to look at the sign chart, or if it's in the negative direction. But in addition to those lines, we also have the horizontal asymptote, which is the x-axis. So there. Now we are ready to sketch the graph. Let's first, for an easier way of just sketching the graph and then just connecting later on, we will start with drawing the graph near the asymptotes, near the vertical asymptotes, and then the horizontal asymptote. So first, let's start with this asymptote here. To the left of it, we see that the sign is positive. So the graph will be asymptotic in the positive y direction. Okay. And then to the right, or okay, from the right towards that vertical line, it will be asymptotic in the negative direction. Again, looking at this asymptote, we have negative from the left, positive from the right, coming from the right towards the line. Sorry. Anyway. And then, considering this one now, negative, positive. It's hard to draw on the screen. There. Now, we next consider the horizontal asymptote, if there's any. So it's asymptotic to the horizontal line, to that horizontal line towards the negative x direction and towards the positive y direction. The only thing you have to know if it's on top of that asymptote or it's below that asymptote using the sign chart. If you look at the extreme left or the leftmost interval here, it's above the x-axis. And this is the x-axis. So that means it will be asymptotic to that line above it. It's coming from above. Let me just extend. So pag ganyan siya. And then again, looking at this one above, asymptotic. And it's not hard to see how those will connect, right? And don't forget, the graph has to pass through the intercept. So if we just merely connect, we have the graph actually ready. And verify the graph is above on this interval, below here, above, okay, below, above. Now, for a more accurate sketch, I have plotted the graph using a computer. That's the smaller version. You see? We have the same. So that's all you need to know for sketching rational functions, intercepts, asymptotes, sign chart. Is there any question? So just practice on the exercises I've put there in the module, okay? So that's it for today unless you have a question.
Sir, how close do you know how to draw the lines? Like for example, po yung sa
Yes.
in between
The
negative
graph has
and
to
negative
point
one.
towards the asymptotes, and to indicate that they are uh, asymptotic, you use arrows pointing in the direction of the asymptotes, not away. Like for example, if you do it like this, it will be wrong since it's now moving away from the vertical asymptote there.
Mm.
So you don't it doesn't have to be that close as long as you give the idea that it's going asymptotic, okay, to that line.
Kahit po yung sa, for example, the one in between -3 and -1, even if we
Saan
draw it
dito sa
closer to
kanina?
the
Yeah, kasi it's computer generated.
sige po,
Yeah,
thank you.
pero since this is manually drawn, madali lang ipakita na ano o idikit doon sa asymptote. Okay? Any more question? Okay, that's it.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.